Hello, hello, hello. Welcome to AstroBiological, the universe in plain human. That's the cover art you see there for the AstroBiological Facebook group. And who or what the heck is AstroBiological? Well, let me introduce myself. Here I am. How are you? Let's just expand my head a bit. Metaphorically speaking, of course. How's it going? My name's Ben. It's good to have you along. This is a live stream, obviously. Hope you enjoy and learn a bit. I run this channel and the AstroBiological Facebook group, and today I'd like to talk to you about the transit method. So let's just shrink me down a little bit. Okay. We will put this picture up here. We will move me to the top. Got to mess around a bit. I'm using OBS here. Here I am again. Hello, how are you? And now, what are we talking about again? The transit method. What's the transit method? That is a method that has been used since the 1990s by astronomers who have been seeking exoplanets. Now, an exoplanet is any planet beyond our solar system. So we've got the ones we all know about: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Neptune, Uranus, and Pluto if you're a bit old school like me. But I also call it a planet. It'll always be a planet in my eyes. But exoplanets, there are a lot of them out there apparently. In the Milky Way galaxy alone. Behind my head just there, that's the Andromeda Galaxy. But they're all much of a muchness really, for the sake of the discussion. In the Milky Way galaxy there are about 100 billion, give or take. So how do they know that, and how many have they found? Well, that's a good question. They've actually found to date around, or just over 5,900, which is pretty good. It seems to be they're discovering new ones every single week. There are some famous examples that have come to light recently, such as the TRAPPIST-1 system, 7 planets orbiting a red dwarf star some 39 light years away from Earth, and they get a lot of my attention. And I'll be doing some more stuff on that in this channel and on the Facebook group. If you want to join the Facebook group, by the way, feel free. Details are in the about section of this channel. So look at all the tabs, video, channel, whatnot, and about, and you'll find links to my Twitter and Facebook group, etc. So let's move on. Excuse me. Okay, so the transit method. Let's get rid of you. And what is it? Let me show you. Okay, so we've got this lovely vista behind me. Very lovely vista. That's let's say it's your typical red supergiant star, a very common class of star, which is observed out there. So we've got a planet comes into view. Let's just move away from this star. And when astronomers are observing stars, and most of these stars are thought to have planets orbiting them, it's obvious that the star it puts out a tremendous amount of light. Now, in a solar system such as our own, we'll call our own a typical solar system. Well, possibly isn't. The Sun comprises about 99% of the mass of our solar system. So even Jupiter, which is vastly more huge than Earth, is basically blocked out by the glare to an outside observer, and that's what's happening to us when we look at other solar systems. We're not seeing anything. We only think there are stars out there, and thus far we've thought that because we just haven't seen the planets until in the early 1990s. Whilst stars were observed, astronomers noticed the occasional dip in the light observed coming from a star. And eventually this was deduced to be caused by something passing in front of the star, and finally they figured out that that was most likely a planet. So that makes sense. If you've ever seen a solar eclipse in real life or on the interwebs or whatever, it makes sense. A planet passes in front of the sun or the moon, and the light is blocked. That's what's happening during these transit events. When a planet passes in front of a star, imperceptibly, I might add, to the human eye, but detectable with instrumentation, the amount of star observed from that light dims. Now, it's tiny, but it's there. So, using the amount of light that's dimmed out, astronomers can not only measure the size of these objects or planets, they can determine its orbital speed based on how fast, by the amount of the length of time dimming occurs, and so on and so forth. They can deduce a lot from just one simple technique, and it's pretty incredible. We'll zip away, get rid of that planet. So there's a star again. We'll find another planet and head there. I'm using Space Engine, by the way. It's a rather fun little piece of software. A procedural generation game. Now, if we wanted to, we can land on this planet and take a look. Who wants to do that? Me! Okay, you talked me into it. Let's take a look. Land on object. No, we're landing on the star. Oh no! Oh no! Oh no! It's hot. Let's get out of here. Oh crikey. I don't know whether a star would look like that. Oh dear. No. We don't want to be there. Let's get out of here. Let's head back into space. Woo. Whew. Yikes. That was crazy. Crazy. But let's try and find a planet. Go there. Alright, that's better. Okay, so you can see this magnificent vista before you. What would it be like to land on this planet? Let's take a look. Go to object. Right. Now we can land on it. Let's go. Oh no. Into the sun again. Ouch. No. I don't know what's happening. Back into space. Let's try again. Anyway, you get the picture. I'm just messing around now. But that's a transit method. That's how astronomers can detect planets around distant solar systems, distant stars. They've detected planets in another galaxy recently, but using a method called gravitational lensing, which I'll explain in a future video. So let's get rid of this. Back to here. I'll go back to the old Facebook cover photo. Put me back on top of there. Hello. Right. I hope you've liked this little stream. Let's just go to YouTube, cross over now, see if anything is happening. Got a couple watching, that's okay. This is just an introductory stream really. I hope you're enjoying yourselves, whoever you are. Top chat. Melanosuchus niger. Transit methods are used to discover celestial bodies, so it's quite efficient. And again, it's how it was discovered that Huamia actually has two moons. And Tabby star is a good case of that light fading glowing because of a theorized celestial body orbiting it. Not only celestial body, many people believe it's actually some sort of alien megastructure. Yeah, I'm not so sure about that, but I think it'd actually be cooler if it was just some sort of natural phenomenon like a cloud of dust or a cometary cloud or who knows what. But any other suggestions? Melanosuchus niger? What do you reckon? They're all good ideas. Thanks for joining the chat, by the way. Okay, so we'll shrink my little old head back down. Right, how's it look? I'm flying blind at the moment. Yep, there we are. My head shrunk back down. Okay, so the stream appears to be working pretty well. I guess while I'm here, again, that's the my Facebook group banner behind me. Let's move it around a bit if we can. There we go, just to get your attention. Join the Facebook group. A lot of people who are into this stuff are there. Some scientists, plenty of non-scientists, but all sharing a common interest in just chatting about this stuff. It's such a wide topic area to discuss too. I mean, you've got a whole universe to explore and talk about really, and a bunch of topics. You can talk about physical processes like transits, like we're talking about now, or anything, life emerging, the process of emergence, or molecular clouds, amino acids forming in space, water on other worlds beyond the solar system. It's really great, and I don't know, I could really talk about it all day long. I do sometimes, but we'll go back to Space Engine just for a bit and see what else we can find, because Space Engine is a lot of fun. Now, excuse me, let's look for, I don't know, the Milky Way. Whoop, there we go. The old Milky Way. You can turn up the brightness a little bit. It's a pretty fair representation of our parent galaxy, and we're in there somewhere. Let's move along the plane of the galaxy towards, whoops, the galactic core. Ain't it fun? There we go, Milky Way. Let's head back to another place we all know and love. Right, zoom. Venus. Bit of a favourite of mine at the moment. I've been banging on about the Explore Venus hashtag on my Facebook group for a bit. I personally think Venus is a bit of a candidate for colonization. I think it's more suitable than Mars in some ways. Mars seems to be more hospitable, and it possibly is, but it also presents some significant challenges to human colonization, and various aspects of Venus actually make it a little bit more feasible, both from a technological and yeah, from a technological point of view. I mean, it's, to all intents and purposes, is a an apocalyptic hellhole. It's fair to say, but this is Venus without clouds at the moment. Looking directly at the surface. I've removed the clouds for the sake of this simulation. We'll put them back. It's covered in a swirling, stormy miasma of carbon dioxide and sulfuric acid rain. Not nice at all. But and that surface is frozen, or frozen in place. It's a wasteland, hot enough to melt lead. On a cool day, it's about 492 degrees Celsius on the surface, so not very nice at all. But in those clouds, in those cloud tops, at certain altitudes, the temperature is about 40 degrees, between 40 to 50 degrees Celsius. The air pressure is bearable to humans, and gravity on Venus is the same as Earth. It's slightly lower, but wouldn't be discernible to us. And the sulfuric acid rain doesn't reach that altitude, so if we could erect, say, like airships or dirigibles that could stay aloft in the upper atmosphere of Venus, we could live there quite easily. And that's why I think Venus is a pretty decent old candidate for colonization. That's just me. I'm going to talk about that on the group and also in future videos. If anyone has any suggestions for videos, feel free to venture forth with opinions and stuff, that's fine. I've had plenty of good feedback and stuff from my my group so far, and other groups. I did a little live stream on Periscope and Facebook a couple of weeks ago. Sent around a post I put up about alien megastructures and what kind of life may live after the builders or inhabitants of the megastructure have perished or moved on, and there was some interesting ideas coming out of that, so I thought I'd make a little live stream out of it, and did okay. So I could talk about that again. I could probably expand on that conversation, I think. Maybe do another video, like a proper video perhaps, or another live stream. If anybody wants to see stuff like that, I'd love to oblige. So we'll go back to space engine, surface of Venus. Where to now? Come on, work. Right. Let's go to Mars. We know we want to. Mars is the golden child, we know. Let's turn down the brightness a bit. There's Mars. Okay. The red planet. The very red planet. Let's turn down the brightness again. Now, Mars has an atmosphere. Let's turn it on. It does have wispy clouds of carbon dioxide, very thin atmosphere. It's physically more suitable to human habitation than Venus is, but other factors make this place in its own way just as harsh and inhospitable as Venus could be. I believe yep, that's Valles Marineris there. I do believe the longest and deepest canyon in the solar system. I looked at that in an early video about extreme places in the solar system. Check it out, it was a lot of fun. It was one of my early videos when I rebranded the channel a bit, and that was the first one. And before that, the channel was a bit all over the place, I guess. Looking at all kinds of stuff. I was still finding my feet. I still am, I guess, but I think I'm improving with each video. I certainly hope so. Zoom out. Let's turn Mars around. Yeah, that's Valles Marineris, of course. It was a fun video to make. Check it out. Extreme places in the solar system. It's somewhere. Look for it. I know where you live. Where can we go now? Alright. Any suggestions for places to go? Type in a little ants to Melody Circus there. Yes, there we go. Nice to have you on board. Okay, so also feel free to share this live cast if you want. I'm not sure how long we'll go for, not incredibly long. I think it's been about half an hour so far, I'm not sure. 20 minutes, that's okay. And we'll go until I decide I'm sick of it. So we've been to Mars. Who wants to go to an asteroid? Asteroids are fun. Ah, yes. These asteroids are awesome in this game, because they're so darn realistic. Well, they look realistic to me at least. We can land on this sucker. Whoop. Oh, fell down. I don't know how I did that. Because I didn't tell it to. Right, okay. Let's take a look. We'll see what's out there. Explore an asteroid. That's a beautiful sight. That's sunrise. Let's go cruising. That's most likely what an asteroid would look like. This is of course a simulation, but who knows. It's getting close. Asteroids may be a source of immense wealth and industry in the future as mining of them gets underway. Who knows? Possibilities are endless. It's a good time to be alive in some ways. Let's look somewhere else. Let's take a look at an exoplanet. Alright, what have we got? Get out of here, whoops. Right, we've got some planets we could explore here. Let's see what we got. Right. What have we got here? This planet is very far away from its sun. Okay. Atmospheres. Where are the atmospheres? Do they have an atmosphere? It does, okay. Good. Let's go down. Right, so we'll fly across this little frozen titan and just gaze at the magnificent vista below. There appears to be some kind of storms over there, I believe. They've gone now, but this is a game where the sky is pretty much the limit. Whoops. Crash landing. Up we go. Right, so and then you can just kind of do whatever you want really. Skim across the atmosphere. It's a lot of fun. Take a look at this planet from space. Here we are again. I'll have to screenshot that, I think. Later. Okay, so 24 minutes we're up to. That's what we'll do for now. Thanks for hopping on. If few watches you, that's okay. It's only a test, but may get watched a bit more later on. Subscribe to the channel. Check out the Facebook group as well while you're at it. There's a fair bit of fun going on there. People from all walks of life and all scientific backgrounds kind of all chucked in the pot. many interesting conversations to be had. So hopefully this channel is getting better with each passing video. That seems to be showing in the growth. Slow, but it definitely seems to be going up now. It's not going down at all. So I really am thankful for that to people who are helping it along. Time to go. Let's get rid of this. Right, so let's expand mate. Right, so again, it was fun exploring the universe a little bit with you. My name's Ben. You have been watching an AstroBiological live stream. This is AstroBiological, bringing you the universe and plain human. See you guys later.